Hi, you guys. So here is our first lecture video. We're going to start diving into statistics with Chapter 1, Introduction to Statistics. And the very first thing that I'd like to do in Chapter 1 is to make sure that we get our statistical thinking cap on. Just think analytically. Okay, so that's what we're going to do in this first section, Section 1.2. And statistical thinking is literally about thinking very critically about the information that is presented to you via statistics, via any kind of numbers. What do they mean? What do they stand for? How were they gotten? And how is there any person that is actually going to benefit from this information, or is this just information so that people would be able to make a decision for themselves? Please note that I will try to speak relatively slow, but I'm going to go through this quick because you can rewind this video at any point and any other future videos. Please also know that in the lecture notes that you guys would be downloading, and if you want print off or just write on the your iPad or tablet, you would be able to go through and just annotate the missing words that I'm going to be now filling in. Okay, so statistical thinking, here we go. Oh, the other thing that I wanted to make sure that you guys are growing in is actually just wisdom. So I put some proverbs here at the beginning of every single section for you guys just to know what the proverb is and then what the more contemporary interpretation is of that proverb. So it matches actually what we're going to be talking every single chapter. So for this first one, for instance, when we dive into statistics, we're going to find out that whatever claim a person makes, that will be found out, whether it's a lie or it's actually the truth, via statistics, right? So the proverb goes, whoever speaks the truth gives honest evidence, but a false witness utters deceit. In other words, truth will eventually prevail through evidence. All you need to do is use statistics wisely, do not abuse it, and you will be getting to the bottom of what the truth, the objective truth is in whatever circumstances, whatever situation you're interested in. Okay? More to come about Proverbs from there. What is statistics? Statistics is a collection of methods for planning experiments, for obtaining data, and then organizing, summarizing, presenting, then analyzing and interpreting the information and drawing conclusions based on the data. So that's a huge blurb right there, but there's basically 3 stages to the statistical process. The first one is gathering of information. The second one is organizing the information via a table, via a graph, via finding out what the information, the mean, median, mode, and mid-range, the variation, how the data varies when you've organized it, and then drawing conclusions. That's the third step, analyzing and interpreting to come up with conclusions based on what the data is actually saying. So there's these 3 stages: gathering information, organizing the information to be able to present it, or organizing the information, and then interpreting or drawing conclusions based on the data. Here's the statistical process in more or less of a diagram, and the diagram there is to describe. So first collect the data, then we're going to be presenting data, and then looking at the measures of central tendency and variability. So I'll be using this one right here. So presenting data. Okay, that's a weird one. Here it goes. Now it's working. So presenting data, collecting data, presenting data, and measures of central tendency is like the second step, right? And that's actually called descriptive statistics, when you're trying to describe the data. And then there's inferential statistics, where you're trying to infer or make conclusions based on the data that's been organized for you. So that's data analysis, okay? Please note that this will be more or less, the first collecting data is going to be chapter 1. Then here's presenting data and then looking at measures of central tendency. This is going to be chapters 2 and 3. There's going to be some chapters in between here that we're going to take a look at, probability, for instance, and then we're going to talk about data analysis for the rest of the semester. So this is more or less the entire semester's work right here in this picture diagram, although there's a lot more stuff right in between here and here that we need to look at. Okay? Uses of statistics. There's a lot of uses. Here's some. Almost all fields of study benefit from the application of statistical methods. Sociology, genetics, insurance, biology, polling, retirement planning, automobile fatality rates, and a lot more. I'm going to give you like 4 seconds right now. Can you come up with some other field that uses a lot of statistics that's not on the slide? Go ahead. Say it out loud. Okay, that's 4 seconds right there. So hopefully you got something else. Just a really quick note, like for instance, insurance, right? If you think about it, how do the insurance companies know whether to raise the prices or lower the prices of their insurance and whatever the coverage that they're offering? Well, that's based on statistics, right? Well, the DMV would say, here's some information. There's been, several 100,000 or tens of thousands of new drivers. Most of them are aged 18, between 18 and 20. And so you guys better raise your prices a little bit more because you should expect to see more accidents on the roads. On the other hand, there's some more information. Maybe a lot of those people that just got their new driver's license now actually went through a school of sorts where they practiced and they get educated about how to drive, and so maybe there won't be as many. So that's another factor. The statistician in the insurance company will take all of this information, put it into a formula, and then actually from the data and the organization of data present to the CEOs. My advice is to raise the prices. Or you know what? You can actually lower the prices and gain more of your competitors' clients, right? So there's several ways this can go. So the uses of statistics is everywhere. Everywhere it's being used. And think about this. If you want to sound very authoritative, there is this subconscious influence of statistics. Try to remember the last time that you were listening to some kind of talk or presentation and somebody used some statistics. Didn't they sound more authoritative? In fact, if you think about this, here's what it says. Statistics is so powerful that it increases the believability of a speech or presentation by 96%. That's crazy. So if you want to be believed or you want to sound more authoritative, just include some statistics in your presentation. Now stop for a moment. I just pulled one on you right now. Can you tell me where I got this number from, 96? You're right, nowhere. I didn't tell you I did some kind of study, but I sounded authoritative, right? I sounded like, oh, he knows what he's talking about because he's given me some number. There's some study behind it. And that's kind of the statistical thinking that we need to do. We need to say, okay, there is a number, yes. I need to be conscious of the subconscious influence of the statistics that's being presented to me. And then I need to find out, how did they do their study? What did they do to get this number, right? And I'm literally claiming to you, I made this number up. So please be aware of the subconscious influence of statistics that people have when they're presenting information to you or when you're presenting information. Here's some more vocab words. Chapter 1 is about vocab. There's going to be a lot of stuff that we need to make sure we understand. I'm going to do this at the very beginning, and then we will be able to use all of this vocab, as we talk about more advanced things. Population. What is a population? It's a complete collection of all data to be studied. Complete collection is the key. A census. The collection of data from every member of the population. So, for instance, the census that we're supposed to be having every single 10 years, approximately, right? It's not actually a true census by definition because there are a lot of people that won't be included. There are people who don't have addresses. There are people who are overseas that are citizens of the United States. There's a lot of people who just will not be included in this, and therefore that was not going to be a true census. Sure, people call it a census, but by definition it's not a census because not every member of the population is asked or data is not collected from them. And then a sample, the collection of data from a subset of the population, a small subset or a group should be a representative group of the population. So here's a diagram or a picture for you guys of population versus sample and a question. So we have a target population, and what we do is we're going to take a sample of that population and then study it. This better be a representative sample of this entire population. And so any information that we are going to gather from this sample is an indication of what is going on in the target population. So a question for you guys to think about. In a study, who determines what the population is? The answer to that is the researcher. The population is determined by the researcher, and a sample is a subcollection of the predetermined group, right? So who determines what the population is they're studying? The researcher is. Keep this in mind, because some people want to just study everybody. No. Be pointed with your questions and figuring out, okay, I'm going to study this particular group of people. That means that you have an ability to ask more specific questions of that group of people, right, than everybody else. Well, here's an example, actually. Let's practice. Identify the population and sample in the study. Population and sample. A quality control manager randomly selects 50 bottles of Coca-Cola to assess the calibration of the filing machine. So there's a filing machine, and there's 50 bottles that are going to be taken out, and there's going to be an assessment made as to how the filing machine is separating them. So what's the population? What is the sample? The population would be all of the bottles of Coca-Cola that go through the filing machine, and the sample is the 50 that were selected, right? So population and sample, subset, and then an entire collection would be the population. Here's another one. An instructor collects the ages from a class of statistics students. This one's a little bit trickier. Think about this. What's the big population? What is the population? And what's the sample? So the instructor collects the ages from a class of statistics students. You might say that the class is the population, right? And the ages are the sample. Remember that that would not be correct, because the units have to be the same. The ages and the class are not the same units. For instance, over here we had bottles of Coca-Cola, and then we took 50 and saw where they were actually put, right? So bottles and bottles. Population was bottles, sample was bottles. Over here, if we say population is ages, the population is class of statistics students, and then the subset or the sample is going to be the ages, that would not be correct. We need actually some more information. If we change the statement a little bit more to say an instructor collects the ages from a class of statistics students, and include the reason for it to study the ages of all statistics students at the college, then we have now a population, which is the students at the college, statistics students at the college specifically, and then the ages of the statistics students, at the college, and then the ages of the specific class would be the sample, right? So here's the population, ages of all statistics students at the college, and then ages of the statistics students in the class would be the sample. Ages and ages, also the same units. So be mindful of that. The population and the sample should have the same units. So ages of students at the college is the population, and the sample would be the ages of students in the statistics class. Statistics, as I've mentioned to you guys, is broken down into areas. First, you, of course, gather the information, but then you describe and then you infer. So describe, the descriptive statistics, will be about organizing the information, pulling out specific values out of the data that's been collected. And then inferential statistics, that branch, if you will, is to come up with conclusions based on the organized data, right? Inferential statistics. The definitions are: descriptive statistics describes data using usually through the use of graphs, charts, and pictures. Simple calculations like the mean, range, mode, etc. may also be used in descriptive statistics. And then inferential statistics uses sample data to make inferences or draw conclusions about an entire population. Please note that on some of these slides I'll have this test question here, which is a good thing to come back to and say, wait, I'm probably going to be asked this. I mean, I might not ask this of you, but this is a good thing to make sure you understand. What is the difference between descriptive and inferential statistics? Well, one is describing through charts and through things like the mean, median, mode, and mid-range and variation statistics. And then the other one, inferential statistics, is about making conclusions, drawing conclusions based on the sample that you have. Okay. Here's a question for you guys to think about. What is the difference between information based on a sample and information based on a population? Pause the video and think about it. No, I'm serious. Pause the video and think about it. Come on, you guys. Pause the video and think about it. Okay, for those of you who haven't paused. Information based on a sample is, by definition, incomplete. It's incomplete because you're taking a sample from the population. You're not taking the population as a whole, right? So you must infer something about the population from the sample. Information based on the population is considered complete because it requires no inferential leap to be made. So because you're studying the population and you are including the entire population, whatever conclusion that you make is about the population. But if you're studying the population and you take a sample of the population and you study that sample, you'll have to make an inference or a guess, a very good educated guess about the population, but that will still be incomplete information because you're looking at a subset of the population, not the entire population. Let's talk about some critical thinking, things to think about when working with data. Again, this is under statistical thinking. The first thing is context of data. Like if I asked you, what do these numbers stand for? They can stand for a whole bunch of different things. They can stand for jersey numbers of some soccer players. X could be men's and Y would be women's. You can also say that these are the weights of the 5 students at the beginning and end of freshman year. Right? Context is important. Here's another picture to make sure you understand. When you look at something very, very closely, like a graph is zoomed in really close, then that you don't see the context of what's happening or the big picture, right? It's like zooming in on a stock, and you bought that stock because it was going up today. But if you actually zoom out, you see that it has a downtrend, and you bought it, and you're going to lose money, right? Something like that. So as it says here, the danger with the studying anything this closely is that you lose sight of the context. Don't study things too closely. Make sure you have a big picture of it as well. The next thing to think about is also the source of the data. When you're working with data, consider where are you getting this information? Who did the study? For instance, here in 2003, a study by Engstrom and Cabot found no statistical significant relationship between secondhand smoke and lung cancer. That's huge, right? You have this association that lung cancer, you can get lung cancer from secondhand smoke as well. It was published in the British Medical Journal. That's big. And it's funded and managed by some Center for Indoor Air Research. So these pieces of information seems to be legitimate in making this claim. So first of all, between secondhand smoke and lung cancer, there's no significant relationship. That's counterintuitive. Well, who paid for this? The Center for Indoor Air Research is a research organization created by 9 tobacco companies. So think about this. 9 tobacco companies who don't want there to be a relationship between secondhand smoke and lung cancer. Of course, they're going to publish it. They're going to, basically market this. But if you didn't know the source, you probably start believing, wait, it's okay to smoke around my kids. It's okay to smoke around other people. No, it's not necessarily the case. You need to look at some details of the research that's being done, especially because the people behind it have something to gain from it. Okay? Sampling method. How you collect information is very important. So for instance, 1936 Literary Digest poll predicted Alf Landon. Do you even know who Alf Landon is? Probably don't, because you know who FDR is, who beat him in a landslide. So Literary Digest poll sent out 10 million sample ballots, asked voters to return them, and 2.4 million responded. That's a pretty big sample size if you think about it. They used lists of phone numbers, driver's registration, country club memberships to select the people who got the ballots. Now, a newcomer Gallup poll used a random sample technique and polled 50,000, a lot less than 2.4 million that responded out of 10 million. And Gallup poll got it right. How come? It's because they used a random sample. Well, you can ask, what was wrong with the Literary Digest poll? Well, who did and how did they sample? Think about this. They used lists of phone numbers. First of all, not everybody has a phone. In 1936, right? Think about that. How many people had driver's registration in 1936? Not a lot of people. Country club memberships? Do you see how they're sampling a specific people? And from that sample, they're inferring something about the entire population. Who's going to win the presidency, right? Who are people going to vote for? Well, they got it wrong because of the way and who they sampled, right? Whereas random sample technique actually got it right, and FDR was the president. So keep that in mind. Sampling is important. Here's the other one, conclusions. So this might be a little bit gross, but here's the story. So a researcher comes in to his lab. He has a frog on his table, and he opens up his notebook, and he's eager to write and says, okay, here's what we're going to do. Take a scalpel and remove one of the legs of the frog. And then he screamed, jump! And the frog jumped. So he writes down in his notebook and says, a frog, when deprived of one leg, can still jump. Then he does this on the second day, because researchers need to take some time, right? They like, whoa, wait, what does this mean? They go and ponder over this. Comes back on the second day, opens his notebook, takes a scalpel, removes the second leg, and then screams, jump! And the frog jumped with 2 legs. He writes that down. A frog, when deprived of 2 legs, can jump. He does this the third day, removes the third leg, says jump, and the frog jumps. He records the same thing. The fourth day, he removes the last leg with a scalpel and starts screaming, jump, jump, and the frog doesn't jump. And you know what conclusion he makes? Frogs, when deprived of all of their legs, become deaf. That is not the proper conclusion to come up with when you're doing this kind of research, right? Please make sure that when you're doing any kind of statistical analysis, include statistical thinking. Make sure that you are coming up with a legitimate conclusion that's coming straight directly from the information that you've gathered from the data and what the data says. Speaking about conclusions, make sure that you don't make a causal statement when there isn't one, when there is just a correlation between 2 variables. For instance, there could be some correlation, but not necessarily causality, right? A study looking at smokers finds that smokers have higher pulse rates. Can we conclude that smoking causes someone to have a higher pulse rate? Sure, but there's other reasons why people have higher pulse rates. Exercise, right? Higher pulse rates. Diet, other pulse rates. There's higher pulse rates. There's other reasons why people can have higher pulse rates, not just because of this. So don't say that one causes the other. There might be a correlation between the two, but one necessarily causes the other. Here's another one. A study found that the larger your foot size is, the higher your reading level is. Well, can we conclude that the size of your foot causes you to have a higher reading level? No, there's something else. There's another variable at play, and it's maturing, right? As a child matures, that maturity and education allows him to read better, not just because his foot's getting bigger. So there could be a correlation between the two, but that doesn't mean there is a causal relationship. One doesn't cause the other. Here's another one. Number of people who drown by falling into a pool correlates with films Nicolas Cage appeared in, right? There's a correlation. You see that by the graph, but one doesn't cause the other, right? Just because you watch that film that Nicolas Cage is doesn't mean you fell in a pool and drowned. So correlation and causation are different things. And practical implications also. For instance, a study looking at Atkins' weight loss diet showed 40 subjects had a mean weight loss of 2.1 pounds after 1 year. Is this statistically significant? That's like water weight, right? Think about it, 2.1 pounds. But on the other hand, if it said that there was 120 pounds after 1 year, that is statistically significant, right? That's not water weight. And so you could market this diet and say, hey, this actually works. Statistical significance is achieved in a study when we get a result that is very unlikely to occur by chance. Okay, unlikely to occur by chance. That's very important. And so in this next section, we're going to talk about types of data. I hope that you have got your statistical mindset on, analyzing, being very mindful of the information that's being sent to you. Now we're going to take a look at types of data.